Okay, so I'm going to go through the keystrokes here with you. Now you may not have a graphing calculator. Perhaps you could ask for a birthday gift or a Christmas gift if you so desire. But it could be handy to have with you. So what we want to do is we want to take a look at this example of a model rocket shot in the air from a roof of a building. The height h in meters above the ground is given by this equation, negative 5t squared plus 35t plus 5, where t is the time since takeoff in seconds. We want to find the greatest height reached by the rocket. Well, first of all, let's take a look at this, how we would put that equation into the calculator. Okay, so there is the calculator itself, and what we want to do is we want to, actually maybe I can just put this down here. Okay, so we want to put in negative 5t squared. Now notice that there's a negative sign here and there's a subtraction sign here. So if it's a negative sign like it is here with the negative 5t squared, make sure you press on this button. This is the negative button right here. So we're going to start off, well, first of all, sorry, I guess I should say that from the main screen, which is just a clear screen, we would press y equals, and then we get the list of equations that we could put in, and then what we'll do is we'll put in negative 5, and then for t we'll just use x, but we use this button up here, that's xt theta n, so we do x, and then the squared button here is squared. So then I'll just show you what it has so far. So negative 5x squared. Okay, and then we will push in plus 35, and then the xt theta n again for the next variable. In the equation it's t, but on the calculator it's n, and then plus 5. And then press enter, and then that is registered. Okay, so then what we can do is we can graph it. Hit the graph button, and we see that the line is kind of out of range a little bit. So what we need to do is we need to kind of adjust the window. This is the window, the viewing area of the quadratic. We see that there's 1, 2, 3, 4, 5, 6. It's around 7 tick marks there. So we see that I press the window button, and we see that the x min, the minimum x value, is negative 2. Maximum is 10. That's not too bad. We can maybe change that maximum to just 8 to get a little closer look. The x scale is 1, so what we were counting along the x-axis there, we're counting up by increments of 1. The y minimum is negative 2. The y maximum was 10, but notice that we didn't see the top of the parabola up here. So what we need to do is we need to change the y maximum. The minimum is fine because we can still see where it crosses the x-axis there. So again, we'll go back to window, and we'll change this y maximum. I don't know, let's try 50. X scale, I'll change that maybe to 5. Or sorry, the y scale. So then the increment markers along the axis, the y-axis, will be in groups of 5. And we'll see if that works. Okay, well, it's getting better. We're near the top of the vertex of the parabola. So I think maybe we should change that again. 50 wasn't quite high enough. So let's try 70. See if that works. And then we'll count here. Okay, perfect. Okay, so now we see a nice close view of the parabola all the way along. Now, we can start doing some guessing if we like. The question asks us, what is the greatest height reached by the rocket? So if we hit this trace button here, we can trace and then just go left and right, and we can see how there's a little cursor on the quadratic that is just kind of tracing. And as we just go left and right, it'll follow along the curve. And so we can go up here, that looks to be close to the maximum around there, and then we can just continue down there if we really want to. But we want to find the greatest height, and without guessing, notice, you might even notice here along the bottom as I move the cursor around the quadratic that the coordinates, the x coordinate and the y coordinate, keep changing obviously. And so down here at the bottom will tell us the exact location of the cursor on the quadratic. Well, we don't really want to guess exactly what it is, so what we're going to do is we'll do second and trace, but when we do second, we're actually looking at the calc, which means we're trying to calculate something. So second, trace, and because the graph is opening down like that, is this going to be a maximum or a minimum value? Okay, so what we'll do is we'll go to second, trace, which is actually calc, and we want to look for maximum. So you can scroll down to 4 if you like, and then press enter. And then it's asking you here, left bound. So it's asking us now, between what two areas should I look? This is the calculator talking. Should I look for the maximum? So we set the left bound. We can just, as long as we're somewhere to the left of the maximum, it doesn't really matter where. So somewhere to the left of the maximum, we want the left bound, so press enter. So that's set up the left bound, and then we'll scroll over to the right somewhere, doesn't matter exactly where, anywhere to the right of the maximum, and then we'll press enter again. So the calculator is going to look between this point and this point to see where that maximum is. Now it's asking you to guess. You don't have to. If you like, you can position the cursor as close to the maximum as the vertex as you can, but it doesn't really matter. I can leave it all the way over here if I like, and just forget about the guess thing, and then just press enter, and it'll do the calculation for me. Oh, I see there's a bit of a problem. Okay, so let's go back here and let's try that again. So second, trace, maybe because I had left the cursor outside the bound, that's probably why. So I'm going to now press 4, and so left bound, and I'll just go over there to the left of where the maximum is, right bound, here, press enter one more time, and it tells me that the maximum is at 3.49999971 and y equals 66.25. Well, we can probably safely round that up to x equals 3.5 and y equals 66.25. Okay, so for the greatest height reached by the rocket, I would say then h, because that's what we're using in the equation, h equals 66.25 meters. Alright, we want to find now how long the rocket is in flight. So what we want to do, we could, if we wanted to, trace, and we could just trace down here and just keep going and going and going until we reach where x equals 0. We can kind of see where the cursor is heading as we continue moving the cursor down to the right. If we could find where x equals 0, when y equals 0, that would tell us the x value, or the time when the rocket then hits the ground again, when y equals 0. Or, quite conveniently, we could do then, as I shift around the paper here, we could do second, trace again, calculate, and we want to look at 0. Where is the 0? Press 2. Again, left bound. Here the cursor is a little bit to the left of the 0 because we see that the y value is positive 7.213. So I press enter there, and so it's going to be searching for the 0 from this point over to some other point. And I'm just going to keep hitting the right key here until the y value is negative, and that's negative 30. I'll just back it up just a little bit to maybe negative 12. Right bound here. So the calculator is going to look between these two boundaries here to see where y equals 0. And then I just press enter because I'm not going to guess. And it says that the 0 is when x equals 7.14. And y equals negative 1 times 10 to the negative 11. So that's negative 0.00000000001 or something like that, which is very close to 0. So how long is the rocket in flight? Well, the rocket's in flight from x equals 0 until this point, which is 7.14 seconds. So t equals 7.14 seconds. Next one, determine the height of the building. Well, the height of the building will occur when, Well, when will that occur? If we're setting off a rocket, how long has the rocket been in flight when we would be able to indicate the height of the building? So what we could do is we can just second trace to calculate again, and value. We're just going to put in the value we want. And so at what time value would the rocket first be set off? Okay, so it would be 0. So time is 0, and that would indicate the height of the building, because time has not changed at all there. So when we set time equal to 0 for both of those, we would obviously see that h is, and as it says here, h equals 5. Or y equals 5, but h is 5 meters high. So probably not a skyscraper in any means. And then when the height is 61.25 meters. So what we can do now is we can set y equal to, or hit the y equal button, go down here, and then we can punch in 61.25. So we're now setting another equation to set up 61.25, and if we were to graph that, we see that there is the line 61.25, and we see that there's two intersection points. So now what we can do, if we could of course again trace and guess, we can move this along and guess where that point of intersection is, or what we can do is we can do second calc, intersect, so we'll press 5, and then so it's asking us the first curve, and the first curve is given as negative 5x squared plus 35x plus 5, plus press enter, and then it changes to the second curve, and the second curve it says y equals 61.25, press enter again, it'll ask us to guess, and then we press enter, and we see that the intersection is at x equals 2.5 and y equals 61.25. So when time is 2.5 seconds. Now we see that there's another intersection point, so what we can do again, second trace to calculate, again intersect, so I'll scroll down to intersect. Now we've already done this side, so this time I'm going to go a little bit closer to the other intersection point, around here. First curve, I'm going to guess and enter here, sorry not guess, I'm going to enter for first curve. Second curve is the second equation, I'll press enter again, guess, no thank you. And we see the intersection is t equals 4.5 seconds when y equals 61.25. So 2.5 and 4.5 seconds. Okay, so that is basically that. Now, I said I would go back briefly to the first equation, the first example, and using the calculator, I found that, at 0, x equals 0, y was 0, x equals 1, y is 4, x equals 2, y is 6, x equals 3, y is 6, 4 and 4, 5, 0. So I saw that there were two values where x, or the y value is the highest. Well, I guess then that I would have to check for a value in between these two, because the y value is the same for both of these, so that means that the maximum would have to be halfway between these 2 points. So again, 2 plus 3 divided by 2 gives us 2.5. So if we plug 2.5 into this equation here, we would get 6.25, which gives us the actual maximum for the ball that Grace has hit. Okay, and then how far does it land away from Grace? Well, we see when y is 0, it starts when x equals 0, of course, and then when y is 0 again, that's when it's x equals 5 meters away from Grace. So the ball lands 5 meters from her, back when it's down onto 0 meters high, which is back on the ground. Okay, so if you don't have a graphing calculator, I'm now going to show you, I'm going to put some buttons on this video, and you can click on the buttons to see another little video regarding a graphing program called Desmos, desmos.com. It's an app you can put on Chrome. It's also a website you can go visit, and if you don't have a graphing calculator, you can still put in these values, find the tables of values that you might like, and then you can actually graph the equations. Okay, So I'm going to show you that, and then you can use that whenever it's convenient for you. Okay, so what I'd like you to do, so you're seeing this at home, maybe do a couple of these at home at the beginning or after you finish the video, and then you can do the rest of them at school. But what I suggest is, because you may not have technology, if you do have a laptop or some other technology to use, you can certainly graph these on your own device if you wish, or you can use a graphing calculator that I'll have available for you. You just have to leave them in the classroom though. So I would suggest do these pretty much first in the classroom, and then go back and do these ones by hand, because it's very valuable to know how to do them by hand and use the technology. Technology is a great way to actually check your results that you graph by hand. Okay, so do the first couple, and have a great evening, and we'll see you in class.